Welcome to Module 2, Session 3 of Engineering Statistics and Linear Algebra course. The contents of Session 3 are bivariate transformation, problem examples and assignment questions. First, we'll know what is bivariate transformation. Let us consider two random variables or bivariate random variables x and y. For these two random variables, we know the means mu x and mu y. We know the variance sigma square x, sigma square y, and also we know the corresponding covariance of xy. Then these random variables x and y could be transformed to new random variables u and v with the linear transformation equation given as u is equal to ax plus by, v is equal to cx plus dy. Now for these two new random variables u and v, we can find the mean, variance and covariance. Now how do we find the mean first? The means of u and v are calculated as, now since this is a linear equation, apply the expectation operator to this equation. E of u will be a, e of x plus b, e of y. Now what is e of u? It is mu u is equal to a, e of x is mu x plus b, e of y will be mu y. Similarly, for this new random variable v, the equation for mean is mu v is equal to c mu x plus d mu y. Now, how do you calculate the variance of this random variable u? Now, what is the formula? As we know from single random variable, what is the formula for variance? Sigma square u is equal to e, u minus of mu of u whole square. Now, what is u? We know the equation here. U is nothing but ax plus by. And what is mu u here? A mu x plus b mu y. Now, substitute for u and mu u. U is ax plus by. Mu u is ax plus b mu y. Since we have negative symbol here, minus of a mu x minus of b mu y whole square. Now, here ax minus a mu x. A is common, x minus of mu x, by, and we have minus b mu y. So that b is common, y minus of mu y, and this will be whole square. Now use the formula a plus b whole square formula. It is a square plus b square plus 2ab. Now how do you write this equation then? Now sigma square u is equal to expectation operator. We have this is constant a square x minus of mu x whole square plus 2ab x minus of mu x y minus of mu y plus b square y minus of mu y whole square. Now since this is expectation operator is a linear operator, now this could be written as what? A square e x minus of mu x whole square plus 2ab e x minus of mu x y minus of mu y plus b square e y minus of mu y whole square. Now what is this e x minus of mu x whole square? It is nothing but what? The variance of x, so that you can write it as a square expectation of x minus of mu x whole square is the variance of x, sigma square x plus 2ab. Now what is expectation of x minus of mu x, y minus of mu y? It is nothing but the covariance of random variables x and y plus, now what is this expectation of y minus of mu y whole square? It is nothing but the variance of random variable y, sigma square of y. Now we know the variance of u. Variance of u is a square sigma square x plus 2ab covariance of xy plus b square sigma square y. Now similarly, how do you calculate the variance for the new random variable v now? The procedure is similar to the how we did for the random variable u. Now how do you read? Substitute for v and mu v whole square, cx plus dy minus c mu x minus d mu y whole square. Now cx minus c mu x is common, take it here. D is common, y minus mu y whole square. Use the formulas, expand this equation. Since e is a linear operator, expand this one. And what is the e x minus of mu x whole square? It is nothing but the variance of x, and e y minus of mu y whole square is nothing but the variance of random variable y. And what is e x minus of mu x, y minus of mu y? As we saw in the previous derivation for u, it is nothing but the covariance of x, y. So that what is the formula? We have it for variance of V here, C square sigma square X plus 2CD covariance of XY plus D square sigma square Y. Now, similarly, we can calculate the covariance of U, and the formula for covariance of U and V is given as AC sigma square X plus BC plus AD covariance of XY plus BD sigma square Y. Now, using these formulas, we'll look at some of the problem examples. First example, the variance of zero mean random variables X and Y are given as 7.05 and 3.36 respectively, and also given that the correlation coefficient for X and Y is rho XY is equal to minus 0.48. The bivariate random variables U and V are obtained from transformation. Now, what are the parameters given as per the problem statement here? It says the variance of zero mean, right? The means of X and Y is 0. And what are the variance of X? Variance of X is 7.05 and variance of Y is 3.36. So that what is written here? What is the variance of X now? It is given as sigma square X is equal to 7.05 and variance of Y is sigma square Y. We have it at 3.36. And what is also given here? The correlation. The correlation coefficient is minus 0.48. So that rho XY is equal to minus 0.48. Now, what are the transformation equation which is given for U and V here? 2x plus y, x plus 2y. Now here, just by looking at this one, we know that this equation looks like what now? This equation looks like what? Ax plus by. Similarly, the V equation is what? Cx plus dy. So that just by comparing these two equations, we know that A is 2, B is 1, C is 1, D is 2 here. Right? These are the parameters which are given. Now, what you need to calculate for this bivariate random for U and V are obtained from this one, and you need to calculate what? Correlation coefficient. The correlation coefficient for U and V, rho U, V you need to calculate. Now, how do you calculate for this one? First, we need to calculate the covariance of random variable X and Y. We know the variance. Now, how do you calculate the covariance for this one? What is the formula for X and Y? We know for correlation of X and Y is nothing but what? Rho XY is covariance of XY divided by sigma X multiplied by sigma Y. So now, since we need to calculate the covariance of XY will be what now? It will be rho XY multiplied by sigma X multiplied by sigma Y. Right? Now, what is rho XY? It is given as minus 0.48. And what is sigma X here? Now, variance is given, which is sigma square X. So that it will be square root of 7.05 and sigma Y will be square root of 3.38. Substitute here, minus 4.48, you get it as minus 2.9507. Now, how do you calculate the variance of U? What is the formula? We already derived this one. Sigma square U is A square sigma X square plus 2AB covariance of XY plus B square sigma square Y. Now, we know this, the variance of X, we know the variance of Y, and also we calculate the covariance of X and Y. Substitute for covariance of XY, variance of X and Y in this equation. A is 2 square. This is 7.05 plus 2 into 2 into 1. And this is a minus 2.9505 plus 1 square and this value. So that you get it as 21.7572. Now, similarly for delta square V is nothing but what now? This could be 2 CD covariance of XY plus D square sigma square Y now. Substitute for this values. We know C is 1, D is 2. Substitute here. Substitute for variance of X and Y. Evaluate this one, you get it as 16.6872. Now, how do you calculate the covariance of U and V? And what is the formula? AC sigma square X plus BC plus AD covariance of XY plus BD sigma square Y. Now substitute all the values. We already have this value. Substitute the values, simplify the equation, so that what you get for covariance of U, you get as 10.0665. Now what you need to calculate, ultimately, you need to calculate the correlation coefficient of U and V. Now what is the formula we have? Covariance of U is equal to covariance of UV, sigma U, sigma V. Now so that correlation coefficient is sigma UV, this rho UV is equal to covariance of UV divided by sigma U and multiplied by sigma V. Substitute the values here, right? And we already calculate the value for variance of U and variance of V. Now, since we have sigma U, it will be square root of the variance value. And what is the sigma V? Square root of the variance of V. Substitute here, multiply for this one. For simplify this equation, you get it as 0.528. Therefore, what is the correlation coefficient for random variables U and V here? It is 0.5283. Now we'll go to the second example. The zero mean bivariate random variables x1 and x2 have the following variances. Variance of x1 is 2, variance of x2 is 4. Their correlation coefficient is 0.8. What is correlation coefficient 0.8? It is nothing but for x1 and x2. Therefore, rho of x1, x2 is 0.8. Random variables y1 and y2 are obtained from this linear transformation equation. So y1 is what? 3x1 plus 4x2. y2 is minus x1 plus 2x2 here. Now, what are the given parameters we have it? The variance of x1 is 2, the variance of y is 4, and the correlation coefficient of x1, x2 is 0.8. And now what is this values here? A, B, C, and D. A is 3, B is 4 here, and C is minus 1, and D is 2. Now, how do you calculate the covariance for x1 and x2? We know the formula. Covariance of x1, x2 is equal to rho of x1, x2, sigma x1 multiplied by sigma x2. The correlation coefficient for x1, x2 is given as 8. And what are the variances given? Now here, sigma x1, so that will be square root of 2 into 4. You get it as 2.2627. So that it will be 2.2627 here. Now, calculate the variance of y2. How do you calculate the y2? We know the formula, c square sigma square x1 plus 2cd covariance of x1, x2 plus d square sigma square x2. Substitute for the variance value, substitute for c and d, and also substitute for covariance x1 and x2 value. Simplify the equation and you get the variance for y2 as 8.9492. The covariance of y1 and y2 is given by this equation. AC sigma square x1 plus BC plus AD covariance of x1, x2 plus BD sigma square x2. So that now calculate the covariance for this one. Substitute all the values and you get it as 30.5254. Now similarly, how do you calculate the variance for this one now? Use the same formula, the covariance of x1, x2, substitute the values here. Simplify the equation, you get the variance as 136.3058. We calculated all the required. What is variance of y1 need to calculate? You need to calculate a variance of y2. Variance of y1 is sigma square of y1, sigma square of y2, and covariance of y1 and y2. And these are the two assignment questions. Thank you.